Now, another topic that we're going to have is specific gravity. Specific gravity has something to do with the density of an object. Now, to further discuss this one, let us have this activity. The first setup is a water, then we put ice on it. Then another setup, also a water with wood. We put them also. Now, the question here is, what happened to the ice cube and the block of wood? Does it sink or float? If we're going to look at the picture, the answer will tell us that our ice and our block of wood floats. Okay? Another question here is, what determines whether something floats or sinks in water? So what is it that determines whether an object will float or not in a water? Okay. So the answer here, whether an object will float or sink, is the density of the two materials. Okay. The density of the materials, for example, on this activity, the density of water compared to the density of wood. The density of water compared to the density of ice. Another question is, how can you compare the density of the block of wood and the ice cube? So, if we're going to compare, both of them floats. Now, the reason behind that, just like what I've told you in answering the question number 2, it is the difference between the density of the materials. Okay. Why does there is a portion of ice and block of wood submerged in water? Why is it that it does not float? Okay, but there are parts of it that still submerged. Okay, it is because of specific gravity. Specific gravity is a ratio between the density of a substance and the density of another substance. On this case, on our activity, the density of the ice and water and the density of the wood and the water. Especially water has specific gravity will tell you a fraction on how much object will be below water while it's floating. For instance, ice has a density of 0.92 gram per milliliter. So its specific gravity is 0.92, meaning 92% of ice will submerge. Specific gravity is unitless in quantity. Okay, let us look at this one. So the specific gravity of water is 0.92 gram per specific density pala, sorry. Density of 0.92, it means 92%. Specific gravity is 0.92. So 0.92 is the density. It means 92%. We have here 1. Since our reference is water, determiner whether it will float or not. 1. This will be 0.92 over 100, which is 1. Okay. So it will give you a 92%. So the 92% of that ice will submerge and 8% will float. Okay. So that is specific gravity, the ratio between two densities of different substance. Okay. You cannot get specific gravity when the substance is the same. For example, water and water. No. They must have different density. Okay, in order for us to know whether an object will float or not. Okay, so specific gravity has a formula. The density of an object over the density of water. On this case, the density of the object is 0.92. 0.92 over the density of water is 1.0 or 1.00. So you get this one, you will get the percentage, which is 92%. So this 92% will tell us which part will submerge. Okay, 92% of ice will submerge while the other 8%, 0.8% will float. Okay, so this is an example of this one. Okay, iceberg. Okay, you will notice an iceberg. 92% is submerged in water, then 8% is floating. Okay. Sir, how about this one? If the determiner of whether an object will float or not is its density, why is it that ship floats wherein it is made of metal? Metal has a greater density compared to uh, liquid, which is water. Why does it float? Simply because of its structure. It has nothing to do with the density. Okay? It is because of the structure of the ship. Okay? The structure of the ship is like this one. There are spaces inside, okay, that allows air inside, allowing our ship to float. Okay? That's why once a ship has a hole on this part and airs are starting to go out, it will sink. Okay? So that is the reason ship can float. That is not because of density. Okay? Okay guys, thank you for watching.